All right, so thank you everyone who is online, and thank you all for being here. And especially thank you, Olga, Professor Olga Battaïa from the KEDGE School of Business in France, in the region of Bordeaux. I learned today actually that it was a merge between the Toulouse Business School and the Bordeaux Business School a while ago, and they become this big and important business school in France. And Professor Olga has been doing a bit of a tour of Australia. She's been in Perth, she's going to Sydney, and she could fit us today. And we're very glad that she could come here and give a talk to us. I know Olga's worked for more than 2 decades now. At the time that I was working with on assembly line balancing problems, and Olga is a world reference in that problem. But of course, not only on that problem, she has worked with things from scheduling to network design. So very prolific and productive researcher. Supervised about 20 PhD thesis already, published more than 250 papers. He's an associate editor in some of the most important journals in the area. So it's really an honor and a pleasure to have you here, Olga. And I'm really glad that you could come, and we're looking forward to you.
Thank you so much. Thank you so much for this kind introduction and also for invitation. I'm really happy to be here with you. So, as Alison said, my main research area is line balancing in different environments. So, in particular, I also worked in aircraft line balancing, on aircraft line balancing problems. So, in production lines of aircraft. But today I will talk about a different topic on which we worked closely with French Air Force, which is related to the maintenance of military aircraft. And so I will give some more details later, just to acknowledge the people with whom we work on this topic. So this presentation is really based on the result obtained by Franco Peschiera, who was my PhD student, who was supervised by Alain Haït, my colleague from Isaïe Supayro in Toulouse, and Nicolas Dupart, who at the moment worked at French military agency. So we worked together on this problem with collaboration with the people from the French Air Force. Okay. So some words about me. Alison has already give some information. So yes, I'm associate editor for 3 journals in different areas: Journal of Manufacturing Systems, Omega International Journal of Management Science in IISE Transactions. So I prepare my PhD at the École des Mines de Saint-Étienne in France. Then I worked for 4 years at Isaïe Supayro. So Isaïe Supayro is the aerospace engineering school in France, the most famous one for our very known astronaut Thomas Pesquet is from Isaïe Supayro. So he was involved in promoting the school as well. And during this period that I started working with Dassault Aviation, who is the French manufacturer of military and some business jet aircraft, and with Airbus, who is a very known company for bigger aircrafts. And so my research was funded by other agency, and I also had the chance to visit different colleagues in the different university in the world. And probably I also would like to mention this project we have now. This is a European project related to the problem of aging population in the world, in particular in Europe. And in this project, we also work on how tasks can be assigned in production system to the different operators with the different health conditions, and how new technology can be used in order to help people to work safely, even if they need to work more. So I don't know how it's in Australia, but in Europe, there's a retiring age is constantly moving far away from us. So we are wondering if at some point it will disappear completely. So I don't know if in Australia it's the same, but in Europe and in France, we have a lot of discussions about it. So some words about KEDGE Business School. So school is celebrating 150 years this year. So we originally 2 schools were founded, one in Bordeaux and one in Marseille. And about in 2017, the schools decided to merge to create KEDGE Business School. So KEDGE apparently is an English word for a small anchor, but nobody knows this word. So it's just something neutral, not Bordeaux, not Marseille, but both of them are very big ports in France. That's why, from marketing point of view, they choose this word that nobody knows. But it's one of the biggest business school in France. So currently we have about 15,000 students. I think 8,000 are on Bordeaux campus. So Bordeaux campus is a little bit bigger than Marseille one. We have about 220 professors distributed mainly between Bordeaux and Marseille campus, and maybe 5 years ago, we really started to develop our campus in Paris. So the school rented a lot of space, and we moved the majority of our programs also to Paris campus. So we started with only 4 professors on this campus, but progressively we increase our presence in Paris as well. And in other city in France, we have a small city close to Marseille, where we have one program on interdisciplinary between engineering and management. And we also have some joint affairs with China and in Africa. So we also have shared campuses in Suzhou, Shanghai, and Dhaka. So our school is triple accredited as a business school. And last year, we were the first French business school in business administration in Shanghai ranking, and 29th internationally. So it was very, it's the first time we achieved this position. It was great achievement for me, because since almost 5 years, I'm associate dean for research of the school. So I am managing the research activities. So here we have some, let's say, the structure of our research. Our 220 professors work in research centers in very different topics. So myself personally, I belong to the center of supply chain, but we also have food, wine, and hospitality. So both Bordeaux and Marseille are important region for wine. So Bordeaux, of course, better known in the world, but in Marseille, they also have some rosé wine, on which we also have a research project. And from somebody who worked in engineering schools before moving to the business school, it was quite cool to find some researchers running the experiments on matching cheese and wine. So, and I'll tell you some funny stories. So some professor from the center, they wanted to organize this experiment with the collaborators of the school, but let's say, unfortunately, we don't have really gender balance at the school. So among administrative staff, our collaborators are mostly female, and among academic staff, we still, I think, have maximum 30% of women, but we try to increase the female presence. So when they send the invitation to come to the experiments, of the person who are mostly present on the campus are administrative staff. So they responded, and like 2 hours after they sent, okay, we cannot accept no women anymore because we don't have the gender balance for the experiment. So it was a little bit funny, but it's not because women are drinking more, it's just because we have more administrative staff present on the campus. So then we have a research center in international business, and I think it's the only one in France. So another center in marketing and new consumption, a big center on sustainability. At its origin, it was the biggest one in Europe. Now other schools also grew up the center, so I'm not sure that we're still in this position, but it's quite big. Then I saw a building on art. We also have strong programs on creative industries and culture, so research on art management. We have a center on entrepreneurship, and in particular on family business, which can be also related to wine industry, just to maybe to show how it is important for Bordeaux region. To your opinion, how many wine producers do we have in Bordeaux region? Sorry, I cannot take the answers from maybe guess a number. Okay, so 10,000. Yes, it's a little bit a problem now because in fact the consumption of wine is going down among the young generation. So currently they try to decrease the production in the region. So some chateaux need to change their activity to something else. So they have also some support from the government, but otherwise they produce too much wine. And so we have 10,000 among almost 10,000 producers, and every year the wine is different, and very often they produce red, white, and rosé. So if you want to taste everything, it can take a long time. And we also have a very important center on sustainable finance. So it was one also the first initiative in France on working how the investors can be advised on not only on economic performance of the companies, but also on environmental and social performance. So how this evaluation of environmental performance and social performance can be integrated in financing. So then also have some labs. Don't know if you have some question about the school. I didn't put some, but if you want to see some picture from Bordeaux, it's possible. Otherwise, we can move to the topic of this presentation, which is related to the flight and maintenance planning problem. So, as I told you, this is a part of PhD thesis which has been defended already several years ago. I will present some main result, but of course, if you have questions, we can discuss it in more details. So first of all, we discussed it a little bit before the talk. The first problems that has been addressed in the literature was a, let's say, civil flight and maintenance planning problem, in which we need to schedule the different aircraft moving from different cities. And in fact, aerospace industry is very well controlled industry. So finally, the risk of, let's say, dying on aircraft is much less than when you work just in the city, because they need to respect a lot of safety procedures. That's why they have very strong conditions on maintenance. So they, in fact, in aircraft itself, it's very complex product. They have a lot of equipment in the aircraft, and each important equipment has its own maintenance planning, which has to be respected. And they also have some constraints on number of flight hours, and also some time constraints, even if the aircraft is not flying, which is not the case for civil aircraft, because it's so expensive, so the company want to use them as much as possible. That's why the maintenance, it's very critical procedure, because the aircraft should be cannot be used for flying, and for the company it's an important issue to try to reduce the number of maintenance and also the duration. So usually this maintenance have three, let's say, they have three categories. So the smaller maintenance, which is counted like in days, medium maintenance, which is counted in weeks. So every X weeks you need to do something else, and big checks, which should be done every X months, but we will take more time. And so for civil problem, since the aircraft is moving across the world or across the countries, there is also the question of the capacity of the airport to perform particular maintenance which is needed for the aircraft. So that's why when we solve this problem, we need to optimize, let's say, the travel path of the aircraft, at the same time respect the capacity of the different airports for performing maintenance. So some companies just do it during the night when the aircraft arrive, and during the night they perform the smaller maintenance in order to have the aircraft ready in the morning to go. And generally it works quite well. Let's say every time you have a problem with aircraft, there is a lot of information in the media, but compared to the number of flights we have every day, finally it works quite well. So it's a little bit different for military flight, a maintenance problem. First, let's say, first difference that normally in this case, the aircraft come back to the same base. So there is no, somehow the problem is easier because we don't need to plan the traveling path. We only need to assign aircraft to the different missions. And it's a little bit, let's say, unfortunate, even not a little bit, it's unfortunate, because when we studied this problem, we were living in very peaceful environment, because we started with, so the thesis was finished in 2020, before we finally came back to the discussion about military operations. So during this thesis, it was like planning missions, but it was very far from the actual, the current situation, when we really have several places in the world where we have active military operations. So, so the first important difference is that so all aircraft they have missions. So in this case, it was not real war missions, but more observation missions. So we are not taking into account the losses of aircraft. But so they need to perform a mission, and then they came back to the basis. And for these missions, we'll see let's say the Air Force, they need different kinds of aircraft, and all these aircraft they have to go through maintenance in the same manner as a civil. They have different maintenance or checks, which the smaller, the shorter one, they need to be performed every X days. Medium ones need to be performed every Y weeks, and the big checks they need to be performed every M months. And these checks, in this particular case for military aircraft, can take up to 6 months. So it means that during 6 months, the aircraft cannot be used. And it's very strong constraint because it's quite long period. So the Air Force managers, they really need to have a scheduler in which they can still complete all the missions they need to complete, and have also the capacity of, let's say, of available aircraft just in case of, and respect all these maintenance constraints. So here, as for civil aircraft, we have a constraint, let's say calendar constraint, meaning that each M month, even if aircraft has not been used, it needs to be maintained. And every F flight hours, we also need to perform this maintenance, this big maintenance check. But in fact, flight hours will depend on the missions to which the aircraft will be assigned. So these are not really, in practice, they're not really correlated, flight hours and months between two checks. So these two constraints need to be taken into account. And what is, let's say, a little bit different here, again, from civil problem, it's that we don't have, this is army, So there is a notion of cost, but it's not the same notion of cost as in, let's say, industrial application. Here, it's more notion of what they call sustainability in the literature, but it's not good word because it's not sustainability in terms of sustainable development. It's more, let's say, sustainability in terms of availability and the potential of Air Force to respond to any particular events that may happen. So what happened here, we have a planning period, which is quite long, which is also a little bit particular, but with this, let's say, defense constraints, so they want to plan for 5 years. And when we know that some, let's say, conflict can appear, dynamically, it may, let's say, seems to be a little bit strange, but with this army, and in the army, they have the procedures, and they need to plan for five years. And if they want, let's say, if they want to have the available aircraft, logically, we can see that the objective will be to minimize the number of maintenance, because less we have maintenance, more we have available time. But if you put this function in the optimization problem, at the end of the period, will be all the aircraft needed to have a maintenance in the time just after. Because if you try to minimize the number of maintenance, what will happen from optimization point of view, we will use all the aircrafts to the end of the period, and in the next period, which is not a part of the problem, we will need to put all the aircraft on maintenance. So to prevent it, we need to also to add, let's say, the number of available flight hours at the end of periods, which complicate a little bit because from one side you have the number of maintenance, from another side you have flight hours. So it's like carrots and cows, but you need to combine them in the objective function to have a practical solution. So this is just a schema which shows how it works. So you have the maintenance here, it's only 2 months, but usually they count 6 months, even if it can be a little bit shorter. It's the, let's say, kind of robustness for them to try to plan for more time. Okay, so we compared this particular problem with the problems that have been found in the literature, and we found a number of constraints on a number of differences from the literature. So in particular, very often in the literature for other air forces, so for military, you can find the Greek and the Canadian and other application. They don't consider the notion of mission. They only have 2 hours to assign. And in our case, it's a little bit different because we have missions with particular number of hours and particular number of aircraft to be used. And not all aircrafts are the same. So some missions may require some equipment which are present on some aircraft and not in others. So it's a little bit more complicated in terms of assignment constraints, and also there are not all of them takes into account the for maintenance both flight hours limitation and calendar constraints in terms of months. So in our problem, what we have as the input data, we have the missions. So the missions, they're really defined by this. So we have planning horizon. In this planning horizon, we have the missions which are defined by the starting ending time, number of aircraft needed, and number of hours flight hours in total. Then for each aircraft, we have information about the current number of flight hours that it performed already at the beginning of planning, and then let's say the number of months from the last maintenance. And then we have the constraints in terms how many aircraft we can put in maintenance in the same time, and how frequently we need to maintain. So in terms of flight hours and months. So first of all, we developed, so we proved that the problem was NP hard. So I haven't put the proof here, but if you're interested, we can discuss. And then, so we will develop, first of all, a mathematical model, just to see how commercial solver can handle the problem. I don't know if you want me to go to all the constraints, but typically all these constraints reflect the fact of the limitation of capacity of maintenance and the constraint on the aircraft, but also we need to respect all the missions. So we need to assign to each mission the required number of aircraft and giving to the required number of hours to each aircraft. So our decision variable will be to which mission aircraft is assigned during the period and how many hours each aircraft will perform for this mission. And another decision variable will define when the aircraft will go to the maintenance. And since here it's only 6 months, we only need to know when maintenance starts, and we have directly the end of the maintenance. So then we can also use some approaches to calculate low and upper bounds on the number of maintenance required for each aircraft, depending what was the initial situation of the aircraft, duration of the planning period, and the constraints we have. So, for example, if the planning period is, I don't know, just giving for understanding, it's not the case here. Here it's 5 years, but if it's 1 year and we need to go to maintenance every 6 months, and each maintenance lasts 6 months, we can already see that it will be at most 1 maintenance or no maintenance. But for 5 years, it's a little bit more complicated to calculate, but still we can deliver some efficient low bound. So we also need to manage the remaining flights, and there is a particular detail. So sometimes, as you can understand, the number of aircraft is supposed to be larger than the number of aircraft required by all the missions in parallel, because we may have some aircraft on maintenance. And in fact, when it's not, let's say, it's not good to not use aircraft for a long time. So there is particular detail. So if we don't use an aircraft for a long time, we need to assign it to some training missions. So we can also have a particularity to create training missions and assign the aircraft to them. So this is a kind of scheduler, simple scheduler that can be where in colors you have different missions. Here in the lines you have aircraft, and you have also time period. So just a representation of the scheduler. As you can see, very often you have some holes because you need to have this availability of aircraft. So it can be also an additional constraint in the problem, the number of available aircraft at each time period. So we may also have a constraint on the number of aircraft at each time period, which not assigned to any mission and not in maintenance. They're just available in case if we need to go somewhere. So it can be also a constraint. So then we traditionally we started. So in this case, we were lucky because we had real data from Air Force, so we could apply our model on the real case. But from the, let's say, research point of view, we wanted also to see how generalizable can be this result. So we also changed the different parameters, and with traditional commercial solver, it was not possible to solve all the problems to optimality during one hour. And even if it is a strategical problem, so usually you have time to solve. Let's say from psychological point of view of manager, is not acceptable to wait too long, in fact, especially in defense. They're not ready to. So we wanted to see how we can improve the solution time for this problem. And Franco work on application on some machine learning techniques in order to try to create some cuts in the problem. And he in fact started with hypothesis that since the number of maintenance per planning period was quite limited, this information could be used to improve the solution time of the problem. So in fact, what he tried to predict is the number of maintenance that each aircraft will have during the planning period, taking into account its initial conditions and also density of the missions that are present in the planning period. So with just general assumption, so he to do it, he maybe so this is so in fact he will train his so he used supervised machine learning, in which he first trained the algorithm solving the problems, let's say, offline, where with different initial conditions, with different density of missions, he tried to calculate the optimal solution and to find a correlation between the initial conditions and frequency of maintenance of aircraft. And based on this this information, create a cut on the average distance between maintenance. And this information was added in initial mathematical model in order to, in fact, reduce the combinatorics of the problem. And here's the results. So he solved 3,000 different problems with simplex, with original. So of course, with learning cards, they're not, we will see they don't really give the optimal solution, but so it's a kind of approximation. But in many cases, it helps to reduce the solution time, and at the end, the gap remains. So here you have you can see the distribution of the gap. The gaps, the gap remained quite small. Taking into account, so here again, the notion of optimality is really particular, because having at the end of the period 100 flighting hours or 102 hours, it's for like 5 years. So for the manager, it's not so critical. But still, in fact, to optimize, we need to have an objective function. So here again, it's the number of maintenance and the number of flying hours remaining at the end of the period. So this is the results that he achieved for these predicted cuts on the number of maintenance. So he can conclude that with this approach, he could get good and fast solution. So as you can see here, in it for 80% of time, the average reduction, the solution time has been reduced with quite small gap for the majority of problem. So I haven't presented it in this talk because it's a little bit more, let's say, touchy, protected, but we have also developed within this PhD thesis decision support tool for the managers, in which they have the data, they can try different scheduling, analyze them. So at the end, our end user was satisfied both by the time of solution and the quality of solution, and also the let's say simplicity of the use for them, because they not go through mathematical model. They just need to push the button, and before this thesis, they were dragging the aircraft in the Excel sheet, trying to find different. It was really manual. For further work, there are more complicated constraints that can be integrated in the mathematical model, and that were not, it has not been done within this thesis. So first of all, the conservation constraints. What does it mean? There is a possibility, as I told you, if we don't use an aircraft, it's not good. So in this problem, we use them for training programs, but there is also the possibility to cover the aircraft with special protection, and it can prolong the time between two maintenance. But you need some time to protect aircraft, and you need some time to unprotect the aircraft. So it cannot be available just in one day. So you need to also plan this additional time to protect aircraft and unprotect at the end. But if you use this procedure, you can prolong the time of maintenance between two maintenance. So, for example, if it's 24 months, then you can have maybe 30. But you will need you will gain some time, but we also lose some time for protecting and unprotecting. There is also the question of equipment maintenance. As I told you, aircraft very complex product, but you know it already. So not only the aircraft have constraint on maintenance, but each equipment has its own planning on maintenance, and they're not really synchronized. So can be also, it was also a willing from the end user, try to plan which equipment can be additionally maintained when we go for this big check. So try to synchronize other types of maintenance when the aircraft is stopped for this big maintenance. And the last point, which is unfortunately even more important now, it's about uncertainty management. So as I told you, when we started, we lived the relatively peaceful world. And unfortunately, since 2 years now, there is much more I don't know how to, hot conflicts in the world. And also in France, there is, so apparently we will send some aircraft to Ukraine military, but all other producers of weapon, they're really overloaded with, unfortunately, with demands. So I don't want to finish with this negative conclusion. I hope that we will come back to more peaceful world as soon as possible. And thank you for your attention.